All right, these are the 4 different types of slope that you're going to run into. Okay, this one right here, if you read it from the left side to the right side, it travels up. That makes it a positive slope. This slope, this line, from the left side to the right side, it goes down. That makes it have a negative slope. The other 2 types of lines are horizontal and vertical. The horizontal line goes straight left to right, and its slope is 0, the number 0. And then the last slope that we have comes from a vertical line, which is the one that goes straight up and down. Come on. And it is called, its slope is undefined. Okay? Give your picture, camera, you want to take a picture of that real quick? Good morning. Sorry. All right, the other thing we're going to talk about real quick before we dive into the questions in this section. I'm using my hotspot now. No, it restarted on the 28th, so I'm good now. I'll just be at the end of the month. So I just need to order one of those things. The other thing we're going to talk about on these lines is what is called the Y-intercept. And we did talk some about that in the last section when we were finding the intercepts of the X-intercept and the Y-intercept. The Y-intercept is where the line crosses the y-axis. So remember, on a graph, you have 2 axes, an x-axis and a y-axis. The y-axis is where your line crosses through, the y-intercept is where your line crosses through the y-axis. So for instance, if my line looks like this, that point right there is its y-intercept. That's where it crosses through the y-axis. Okay, so this information should help us go through the first part of this section. Number 1 has a graph that looks like this. Got an x-axis and a y-axis. And its line looks something like that. It's going to ask you 2 questions about this line. It's going to ask you if the slope is positive, negative, or 0. And if the y-intercept is positive, negative, or 0. So let's see. So here's my line. Remember, you read it like a book from the left side to the right side when you're trying to figure out the slope. So from the left to the right, which direction is this red line traveling? From this side to that side, it's going up, which means its slope is positive. The y-intercept So here's my y-axis, and here's where it crosses the y. That's its y-intercept right there. So let's talk about what makes it positive or negative. When you're talking about the y-axis, this point right here there's where 0 is, right in the middle. These numbers are going up. Then below it, it goes down, which means if it's below this point right here, that y-intercept is going to be a negative number, right? It's below 0. So the slope is positive because it goes up from the left side to the right side, but it crosses the y-axis in negative territory, right? Here's 0. If it crosses below here, which it does, that means its y-intercept is negative. All right, let's look at the second one. All right, we're trying to leave everything up there except the line. Let's go what the second line looks like. In number 2. So it looks something like this in number 2. So the first thing on number 2, it's going to ask you the same 2 questions. Is your slope positive, negative, or 0? You're reading it like a book from the left side to the right side. So here's my left side. Here's my right side. What is this line doing from the left to the right? Going up or down? It's going down, which means its slope is negative since it's going down. Where is its y-intercept? Where does it cross through the y-axis? It crosses through right here. That's where the red line crosses through the y-axis. So is this point where it crosses through the y, is it in positive territory or negative territory? Is it above or below this line? It's negative because it's below that line. So its y-intercept is also negative. And then the last one of these kind of lines, or these kind of problems, a horizontal line that looks like that on number 3. Now, remember at the very beginning of class when I had those 4 different types of slopes. If it goes up from left to right, it's positive. If it goes down from left to right, it's negative. If it's horizontal, the slope is 0. And if it's vertical, the slope is undefined. So this is a horizontal line, which means its slope is 0. That's when the slope is 0 if it's horizontal. Where is the y-intercept? Where does it cross through the y-axis? Here's my y-axis. Here's where it crosses it at this point right here. Is that in positive territory or negative territory? It's in positive, right? It's above the origin. So its y-intercept is positive. section is all about slope. We can find the slope in several different kinds of ways depending on the information of the problem gives us. Okay, so I'm going to write it over here. The first way that we're going to visualize slope is by using what's called the rise over the run. We'll talk about it in a minute. If you are given 2 points and asked to find the slope, you're going to use what's called the slope formula. So 2 things. Sometimes you will be given a picture and it will have a value for the rise, the up and down motion of the picture, and the run, which is the left and right distance in the picture. Sometimes you won't be given a picture at all. You'll just be given 2 points, and it'll say these 2 points are on the same line. What's the slope of that line? That's when you'll use this slope formula if you're given 2 points. And the last way, again, this is notes that you're going to want to keep for the rest of these problems. If you are given an equation, of a line and asked to find the slope, you will put the equation into what's called Slope-Intercept Form. Sorry, let's try to. Which is y equals mx plus b. When you put the equation into slope-intercept form, another way to say that is solve that equation for y. Once you solve the equation for y, once you get the y by itself, the number hooked on to the x is the slope of the line. Get that down. So again, let's run through these 3 different things that we're going to look at. There's 3 different ways to find your slope. The depending on what information you are given. Sometimes we're given a picture, and the picture will look like, it'll look like this, and ask you to find the slope of this line. This will be the rise information. This will be the run information. The rise is the distance that it's going up and down. The run is the distance that it's going across. So sometimes we'll be given that information, and we'll simply put the rise number over the run number. Sometimes we're not given that information. Sometimes we're given 2 points. Remember, points come in this form, with an X coordinate and a Y coordinate, and you'll be given 2 of them. If you're given 2 points and need to find the slope, we're going to use that slope formula. And the last way, sometimes you're given an equation. If you're given an equation of the line and need to find the slope, you are going to do what this step says. You're going to put it in what's called Slope-Intercept Form. And what that means is y equals mx plus b. When the y of the equation is all by itself, the number that's hooked onto the x in the m position is the slope of your line. So let's look at some of these. So number 4 in 3.3 gives us the pitch of a roof. So this is the rise, and this distance right here is the run. It tells me the rise, this right here, is 12 feet. Tells me the run, which is this distance right here, is 20 feet. It tells you that in the picture. And it says the pitch. The pitch is the slope of the roof. Is what? Well, if I'm going to find the slope of this roof, I need the rise number over the run number, and then just simplify that fraction. So what's my rise? Well, over what's my run? 20. Now remember how to make your calculator reduce fractions for you? Type in your fraction, so 12 divided by 20 to give you 12 over 20. Then hit enter, it's going to give you a decimal. To reduce your fraction, you hit that math button. So hit math, and then hit enter twice. It'll return that fraction into its simplest form. So 12 over 20, if I reduce it, turns into 3 over 5. So the slope or pitch of that roof is 3/5. Number 5. Got a slide. It gives me the rise over the run. It says my rise is -6. My run is 10. Again, if you want to reduce that in your calculator, -6 divided by 10, and then math, enter that, and what does it tell you? What kind of 3/5? Good. 3/5, right? And that goes along with our slope. Look what, if I read this from the left side to the right side, what is this slide doing? Going down in that negative direction. Number 6 gives us a picture on the graph. So x-axis, y-axis, the line looks like this. And it asks for the slope. Remember what we said at the beginning of class, that's a special kind of line, right? Horizontal and vertical lines have special slopes. They don't have a rise, they don't have rise over run slopes. They got special slopes that we just need to remember. If it's horizontal, the slope is 0.
If it's horizontal.
If it's horizontal. If it's vertical, if my line would have looked like this,
It's going to be a negative.
if it looks like this, if it's vertical like that, that slope is undefined. Right. This slope is undefined for vertical lines. All right, on problems 7 through 11, the problem is going to give me 2 points that are on the line. It's not going to give me any kind of picture. It's going to give me 2 points on the line and tell me to find the slope of that line. So, out of the methods, if you are given 2 points, you are going to use that slope formula. I'm going to work one before I get to that specific problem, because there's a bunch of negatives in there. I want to do one first that doesn't involve a bunch of sign issues. All right, so remember our slope formula is y2 minus y1 over x2 minus x1. So I'm going to make up a problem instead of doing that next one. So the problems will look like this. It'll give you 2 points and it'll say find the slope. That's how I know I need to use this slope formula. Now remember, let's name these points. If I have a point, that means I have an x-coordinate and a y-coordinate, because it's very important where you put each one of these numbers in the formula. So that's a point, which means it has an x-coordinate and a y-coordinate. This is another point. It also has an x-coordinate and a y-coordinate, right? All points have that x and y. What you're going to do is just designate one of these points as being point number 1 and the other point as being point number 2. It really doesn't matter which one. Okay, so I'm going to designate this as being point number 1, which means its x and y are both 1s. I'll designate this one as being point number 2, which means its x and y are both 2s. I highly recommend that every single problem that you do that has the 2 points, write this out. Write out xy, xy, give one the 1s and the other one the 2s. If not, you kind of lose yourself in the middle of the problem on who's what and what number and what letter and everything. So go ahead and write it out. Even if you think you're going to remember it, write it out. Because now I simply plug in the numbers where they go. So let's see, it's going to be a fraction. In top, I've got my second y. What number here, since I have it labeled, is the second, which is y2? That's this number right here. Minus, that's the formula, it says to subtract. What's your first y, or y1? Good. See what I'm saying? If you label it ahead of time, you don't have to try and go back and think about what's what. You just go and pick which number is in that spot. So y1 is 7. In the bottom, I need x2. Who's x2? 5. What's the formula say to do? Subtract. What's my x1? 3. Now, do the math. So up top, be careful, I have 2 minus 7. I would just type that in your calculator. What's 2 minus 7? Negative 5. Over 5 minus 3 is 2. And since that doesn't reduce, that is your slope. Negative 5 over 2. Now let's work the one that is in the homework. That's got all the negative signs with it. This is where it gets tricky. But again, just label everybody x1, y1, x2, y2. Plug it in and then use your calculator. Number 7, the points are negative 15, negative 9. And negative 16, negative 14. Now, remember what you're going to do. Label them first. This is an X and a Y. Is this a point? Another X and a Y. Designate one of them as being the first point. So this, I'll just make this one my 1s and this one my 2s. What you can't do is within the same point have a 1 and a 2. The whole point is your 1s. The other whole point is your 2s. So let's plug it in. My formula said I need my y2 first. Who is y2? So negative 14. Now be careful here. What does the formula say to do? Always. So go ahead and put your subtraction symbol in there. What do you do next? What's your y1? Negative 9. Then in the bottom, what do you need? x2. Negative 16. Minus. Go ahead and put your minus in before you even look at the other number. So negative 16 minus my x1 is negative 15. Type it in exactly how you see it. So I need, up top, I need negative 14 minus negative 9. So when I type that in, I type it in exactly like that. So negative 14. Now remember the difference between the minus and the negative button. This becomes important on this part. So I first need the minus, so the regular minus button. And then what am I subtracting? Negative 9. So now you need the negative button again. Whoops. Negative 9. So negative 14 minus negative 9. Enter. Gave me negative 5. Do the same thing in the bottom. So negative 16, and then your minus button. And what am I subtracting? Negative 16 minus negative 15. So now your negative button. And enter. So in the bottom, I have negative 1. Good. Why is that equal 5? Because they have a negative over a negative, which makes it positive. If you're not sure, type that in your calculator, -5 divided by -1, and hit enter, and it tells you +5. Right, number 8. The points are at 1, 7 and 8, -1. Label. So x, y, point 1, point 2. So 1s and 2s. Plug them in. Up top, I need my y2. So my y2 is -1. What do I go ahead and put in before I look at anything else? Minus. What's y1? 7. The bottom, x2 is 8 minus my x1, which is 1. Plug it in. Up top, what do you have? You've got -1 minus 7. So when you plug that in, -1 minus 7 gives you -8. Eight minus 1 is 7. If you math enter that, what does it tell you? -8/7, which just means it was in lowest terms.
Is number 9 the same?
Yep. Oh, it's gonna come up funny. You'll see. Now let's talk about something. You know how the slopes that we have found so far have either been positive or negative. Now remember the other two slopes, there's a slope of a horizontal line that's 0 and a slope of a vertical line that is undefined. This will come up in these kind of problems also. When you are doing this, if your 0 comes up in the top of your fraction, that means your slope is 0. If when you are solving them using this method, and your 0 comes up in the bottom of your fraction, that's right. The slope is undefined. Right, because you can't divide by 0. 0 over anything is 0. But this says you're trying to divide something by 0, and that's undefined. So let's look at number 9. You've got 6, -1. The -10, -1.
What's this number 9?
Number 9.
Okay.
Label, xy. First point and second point, so there's my 1s, there's my 2s. Plug into the formula, so I need y2, which is -1, minus, what's your y1? It's also -1. Over x2 minus x1. x2 is -10 minus, your x1 is 6. Let's type that top into my calculator. So I need to type in exactly what I see. -1 minus -1. What does that tell you?
0.
It gives you 0. which doesn't even mean, so it doesn't even matter what that's going to be. Because if you have a 0 in the top of your fraction, the slope is 0. Okay? So you do answer the A option. The slope of the line is, you just put the number 0 in there. Okay, this would end up giving me negative 16 down here, but it wouldn't matter because if there's a 0 up top, the slope is 0. Number 10, the points are at 6, negative 4, and 6, negative 10. Same process. That's an X and a Y, that's an X and a Y. First point and second point. Plug it in. So I need Y2, which is negative 10, minus Y1, which is negative 4, over, my X's are at the bottom, X2 is 6, minus 6. So this time, just looking at that, what am I going to get in the bottom? What's 6 minus 6? Right. That's going to be 0 down there, right? So that one's going to end up being undefined. It's not going to matter what the top is, because if the bottom is 0, it's undefined. If I did type this in, negative 10 minus negative 4, it would give me negative 6, but it doesn't matter, because I had a 0 in the bottom. So that's when you would check the B option. Right here, the slope is undefined.
And then number 9 was
0.
A option.
A option, the number, instead of typing in 3/5 or something, you just type in the number 0. And the last one like this, number 11. This has decimals, but that's all right, we got a calculator. Negative 11.6, 8.2 is the first point, negative 11.1, 3.2 is the second point. Again, label. First point has an X and a Y, second point has an X and a Y. First point gets my 1s, second point gets my 2s. And then plug it in. So my formula says I need Y2. So who's my Y2? Again, label first. 3.2. Minus my Y1. Good. 8.2. In the bottom, I need X2. Who's my X2? Well, I've labeled it right here. It's negative 11.1 minus, right? Go ahead and put the minus in. And then what are you plugging in for your X1? Negative 11.6. Definitely not trying to do this by hand, right? I just type in using my calculator. 3.2 minus 8.2 gives me negative 5. Then I have negative 11.1 minus, so go ahead and put in negative 11.1 and then put in the minus, and then you need to type in negative 11.6. So remember the difference. Here's my negative button. Negative 11.6 is 0.5. Is that what y'all got?
Yeah.
0.5. Now, it does say to simplify your answer. So what do I need to do? Type this into my calculator. So negative 5 divided by 0.5 gives me negative. Now, the last two problems, and also going into 3.4. This is a good segue into 3.4. It gives us the equation of the line. It doesn't give us 2 points. It doesn't give us a picture. It gives us this information. If you are given the equation of a line and asked to find the slope, you will put the equation into what's called Slope-Intercept Form, which actually means to solve the equation for y, or get the y by itself. Once you get the y by itself, the other side, the number hooked onto the x, is the slope of the line. So before we do the next problem, before we do 12, let's look at a couple of examples that are already in slope-intercept form. So both of those examples are in slope-intercept form. You're in slope-intercept form if y is by itself. In both of these examples, y is by itself on that side equals 2/3 x minus 7. In this example, y is by itself. It's just on the other side. It doesn't matter. If it's by itself, the other side is the mx plus b. So if this rule says if the y is by itself, the number hooked onto the x is the slope of the line. So the slope of that top line is simply 2/3. This bottom one, the y is by itself, which means the number hooked onto your x is your slope. So the slope of this bottom line is negative 4/5.
Ooh, no, 12 don't look like that.
Let's look at another one before we do number 12, because I see something that's going to come up. So y is by itself, which means the number hooked on to x is your slope. 7 is not hooked on to x, it's below it. So what this is really saying, what number is in front of this x right here? I just don't see it. 1. So the number hooked on is actually 1/7. So the slope of that line is 1/7. You see what I'm saying? It has a 1 in the top and a 7 in the bottom. With the 7 in the bottom, that told me that there needs to be a top, right? You can't have a bottom of a fraction without having a top. So that's why I needed to realize there's a 1 in front of that x. So the number that's hooked on to that x is actually 1/7. We're going to see that in number 12.
So that means that it's gonna be underneath it gonna be 1.
If there's nothing underneath it, yep.
So it's, okay.
Yeah. That's a good point to bring up that we're going to see later. equals x plus 6. So the y is not by itself. The reason we do chapter 2 before we do chapter 3 is we have to know how to solve equations. We have to know the rules to solve equations, to get what we want to be by itself, by itself. What do we want to be by itself? Y. Who needs to go away in order for y to be alone? That 3 does. What do you do? That 3's hooked on, so what do you do with numbers that are hooked on? To get rid of them. Not subtract because it's not added. Divide by it, right? I'm going to divide by 3. If I do it to this side, I have to do it to everything on the other side also. So the 3 cancels the 3. There's my y equals. That's what I wanted. Here's why I did that one little example right before this. What's in front of this x that I don't see here? A 1. So I have 1 over 3x plus 6 over 3 is 2. That number's not important for this problem because what do I need to know? When y is by itself, the number hooked onto x is your slope. So the slope of this line is 1/3. Number 13. Negative 7y minus 6x equals 5. I got some work to do in order for this y to be alone. Now remember, the number that is hooked on goes away last. I need to get rid of minus 6x, right? My goal is to get this right here all by itself, which means everybody else needs to go away. So if I'm going to get rid of minus 6x, how do I undo minus? Plus. So I'm going to plus 6x. If I do it to this side, I have to also do it to the other side. So it gets rid of the minus 6x on the left. So all I have on the left now is negative 7y. Drop down your equal, right? Keep your equal in the same spot. Now, what's on the other side of that equal sign? One's an x and one's a plain number. You can't put them together. They're not like terms, which just means these are two separate terms that are just going to drop down. I've got a 6x over here, and I've got a plus 5. You could put 5 plus 6x. It doesn't matter. They just can't go together and make an 11, right? Because one's an x and one's not. Almost done. What needs to go away now? Negative 7, and it's hooked on, which means that's what I'm going to divide by. Negative 7. So my negative 7's cancel. Y equals positive over a negative just makes that what? What's a positive over a negative? Is it positive or negative? Negative 6 over 7x, right? That doesn't reduce. Now this other number doesn't even really matter on this problem, right? But a positive over a negative is still negative, and 5 over 7 doesn't reduce. These are going to take some practice.
So that means your slope is going to be
Negative 6/7 is the slope. Once you get the y by itself, the number in front of x is your slope. Okay, I'm going to pause this for a second. I'm going to put one on the board for you to try. So if I'm going to get y by itself, here's my y that wants to be alone. I need to get rid of this first, right? 5 goes away last since it's hooked on. To get rid of minus 4x, I'm going to add 4x. So now I'll just drop down that 5y.
What number are you doing?
I'm just doing an example.
You doing the -10 plus 4x?
You can do that. You can either do 4x, they just have to come down separately. They can't go together. So you're either going to have a 4x minus 10 or a -10 plus 4x. It doesn't matter. They just can't go together. So either way you want to write it. Either 4x and then the minus 10, or like you said, then minus 10, then the plus 4x. Either way is right. Then what are you going to divide everybody by? 5. So my y is by itself. Let's see, what do I have on the other side? What's going to be in front of the x? 4 over 5, this doesn't reduce. Minus 10 over 5, which is 2. What's the number hooked on to the x? 4/5. So even if up here you put the minus 10 and then the plus 4x, you're still going to have 4/5 hooked on to your x. Doesn't matter if it was in front or behind the minus 10. Now, this last problem of this section, that was just another example to get some more practice. So let's look at 2 different examples. Sometimes you have an equation of a line. Most lines have an x in it and a y in it, right? Where you have y equals mx plus b. You've got a y and an x. If they don't, this is going to fall in one of those special slope categories, 0 or undefined. So now we just need to see which is which. If it's y equals 7, if I graph that, it's going to make a horizontal line. Horizontal lines have slope is 0. So if there is no x in your equation, which means you can't put it in y equals mx plus b because there is no x. It's because it's a horizontal line, and if you'll remember, the horizontal lines, the slope is 0. The other way, if there is no y in your equation, if you graph this, it's going to make a vertical line. And its slope, what are vertical line slopes? Which one is that? Undefined. So number 14 is going to fall into this category. The equation of the line is x equals -2, which means what would its slope be? If there's no y involved, it's a vertical line. So its slope is undefined. Go ahead. Go. See? There's no y involved. It's just an x.
Okay, so
If there's no, okay, let me write it.
but if you got both of them, then the slope is horizontal and it's 0.
No, if you don't, if this one, if you see this one has, it doesn't have an x.
Mm-hmm.
That means
Okay.
it's 0. Most lines have an X and a Y.
Mhm.
What? Sorry, I'm trying to Venmo.
Oh.
That's a doctor, and he's like,
Oh.
he's trying to check out. He's like, I don't have any money. I'm like, why do they want it?
You know what a problem like number 5?
Uh-huh. Is that the rising line?
Yeah, but you have to here.
So you're just gonna put this number over that number, and then math, enter. So you'll do 20 over 28. Here you'll do negative 12 over 21, and then math, enter to reduce it.
And that's all I do.
Mm-hmm. Good morning.
Sorry.
All right, now we're going into 3.4. We're going to start this off because I want to show y'all how to graph in Math Lab and give you some good pointers on how to make it easier on yourself, what buttons to use.
Miss Nancy, can I come out of this homework?
What?
Will it let me come out of it?
Yep, it'll say if you've entered an answer, it saves it. You can go back in later and it's still answered. You don't even have to click save, even if you just X out of it.
Oh my God. I ain't done though, and I saved it.
That's right. Oh, that's fine. You'll still. It doesn't matter.
It'll let me go back.
Mm-hmm.
Okay.
Yep. Okay, in 3.4, number 1 goes along with exactly what we were just doing over there, identifying the slope, but then it's going to ask for something else. It's also going to ask for the Y-intercept. And remember what the Y-intercept tells you? That tells you where your line crosses through the Y-axis. So, is this in slope-intercept form, or in other words, is Y by itself?
Yes, why by?
Y is by itself. That's exactly what you want. If Y is by itself, the number in front and that's hooked onto the X is your slope. Remember, this is the tricky one. What's in front of that X that I don't see?
1.
So, what's the number hooked on to the X?
1/7.
So, the slope is 1/7. Your Y-intercept. Remember what the equation stands for? You have Y equals mx plus b, where the m is your slope. The number that's not hooked onto the x is your Y-intercept. So the number hooked onto your x is the slope. The number not hooked onto the x is your Y-intercept. Looking at here, what's the number not hooked onto the x? It's sine and everything.
5.
What's this whole number?
5.
Negative 5/11 is the Y-intercept. So if I have, let's just do another one before we jump into graphing. Is the Y by itself? Yes. Which means on the other side is your mx plus b. The number hooked on to the x is your slope. The number not hooked onto the x is your Y-intercept. So looking at this one, what's your slope? What's hooked onto the x?
Negative
Uh-huh.
And then the other gonna be, the Y-intercept is gonna be 1/1.
Right, so what's the number not hooked onto the x? Positive 1, so your y-intercept is 1. Your slope is negative 2/3, your y-intercept is 1. So let's use the slope and y-intercept to graph lines. This was, you know, we were graphing lines in the other one, by using the intercepts or making that little XY table and plotting points. Once you've done it this way a few times, I think you're gonna like it better. It's easier to do it in math lab.
And what was the problem number?
I'm sorry?
What was that you were doing?
3.4, number 1.
Number 1, okay.
Yeah, so now we're going to, on the rest of this section, use the slope and the y-intercept to graph the line. So I'm going to write the steps.
Are we still on number 1?
No, we're getting into number 2.
Oh, okay.
So if you're going to graph an equation by using its slope and y-intercept, which is the easiest way to graph a line, the first thing you want to do is solve the equation for y, and that is so your equation, you will know the slope and y-intercept, right? Because if you solve it for y, the number hooked onto x is your slope. The number not hooked onto x is your y-intercept. So you want to solve it for y first so that you'll know those two numbers. The first thing you're going to do is put a point on the y-intercept. So whatever this number is right here, that's your y-intercept. What is the y-intercept? It's where the line crosses through the y-axis. So you're just going to go straight to the y-axis and put a point on whatever that number is that's in that spot. After that, you're going to count out the slope, starting from that point that you just put on the y-axis. We're going to do several of these. When you get to your stopping point, once you've counted out the rise and the run, you're going to put another point where you end up. And you're going to connect those 2 points to draw the line. So let's look at number 2. Y equals 3x plus 1. Step 1, solve the equation for y. That's actually already done this time, right? The y is by itself. So I don't even have to do that step. Y is already by itself. Step 2, put a point on the y-intercept. So when I'm looking at this equation, if this y is by itself, here's my mx plus b. So let's just say I need to know 2 things. I need to know the slope, and I need to know the y-intercept. What's the slope of this line? What's hooked onto the x? 3. If your slope is a whole number, put it over 1. Your slope needs a rise and a run. It needs a top and a bottom. So if it's a whole number, put a 1 underneath it. What's my y-intercept? What's the number not hooked onto the x? 1. That's all I need to know. So, solve the equation for y. I wrote out what my slope and my y-intercept were. Because those are the two numbers I'm going to need. Put a point on the y-intercept. What's my y-intercept? +1.
+1.
Where's my y-axis? This one right here, correct? That means you just go to the y-axis and you put a point on +1. That's step 2. Step 3 is you're going to count out the slope starting from that red point I just put. When I get to my stopping point, I'm going to put another point. So my slope says to go, this number is my rise. This number is my run. Remember, it's the rise over the run. So from this point is where I start. I'm going to rise 3. 1, 2, 3. I don't do anything yet. I got to do rise and run. Here's why. If your slope is a whole number, you have to put it over 1 because 1 is your run. So I rose 3. Now I'm going to run to the right 1. So I rose 3, ran 1, dropped my next point. Now MATLAB, once you put that second point, it automatically connects them. But that's what the third step is. Once you get a second point, you just connect those 2 points, and that's your line. So again, solve the equation for y. Put a point on your y-intercept, which means whatever number is not hooked onto x, you're going to go straight to your y-axis and put a point on that number. It's for the rest of them, actually. You're in 3.3. We're in 3.4. We already did 3.3. We're in 3.4 now. So, after you put a point on that y-intercept, what are you going to do? You're going to count your rise and your run. Wherever you end up, you're going to drop another point and then connect the 2 points that you have showing. Now, let's talk about this rise and run stuff, right? Sometimes your slope is positive and sometimes your slope is negative. My slope was positive, which means I should end up. Remember how to tell a positive slope if you read it like a book? From the left side to the right side, you should be going up. So, if your slope is a negative number, if your slope is positive, you can always go up and right. If your slope is a negative, just turn your rise negative. Go down and right. That will make the slope be a negative slope. And we'll get to one of those in a minute. Let's look at number 3. Y equals 8/9 x minus 3. Is y by itself. Yeah, which means I can skip step 1, right? I don't need to do step 1. So the equation's already solved for y. So once it's solved for y, let's label our slope and y-intercept. Who's the slope of this line? Which number is your slope? What's hooked onto it? Good. What's your y-intercept? In sign included, it's the number not hooked onto the x, which is what? -3. That's all you need to know. So I know my slope and y-intercept. put a point on the y-intercept. So where am I? I'm going to my y-axis, and where am I going to put a point on it? -3. My slope is positive 8/9, which means I'm going to rise 8 and run 9. Uh-oh. I need to be able to run farther.
Ain't no more road.
I know. 1, 2, 3, 4, 5, 6, 7, 8, 9. So from here, where do I start my rise? From this point that I just put on there, you're going to rise 1, 2, 3, 4, 5, 6, 7, 8. Don't do anything there. Run 9. So you're going to run all the way 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where that point will be. Now, everybody, if you go ahead and go, I want you to go into 3.4, number 2.
Okay, I gotta get through.
You don't have to get through it. You can come back to it. I can't. Put down. Go to, what I say, go to number 2.
3.42.
That's fine. We can come back to it. Oh. We'll come back. So, your equation should be in slope-intercept form. Correct? So, pick out your, tell the, I'm going to share my screen for the people at home. Write down your slope and your y-intercept of your line. Now, remember, you've got to tell MathLab what shape you're going to draw. So click on that, what does it say? Click to enlarge graph, click on that. Once you click to enlarge graph, you're going to have to go over there in that palette that has all the different shapes. I go to number 2. I got my slope and y-intercept. Come over and you go to the line tool, right? To tell it you're about to draw a line. So once you tell it you're about to draw a line, go over to the graph and put a point on the y-axis at whatever your y-intercept is. Okay, mine says 4x plus 6, so my y-intercept is 6. So I'm just going to go to my y-axis and put a point on the 6. You put a point on whatever your y-intercept is. Then take your hands off the graph, off the mouse. Your slope should be a whole number, right? So think of it as over 1. So you're going to have a rise and a run. Instead of, mine is. So my slope is 4, which means it's 4 over 1. I'm not going to use the mouse. I'm going to use the up, down, left, right arrows on the keyboard. So my rise is 4 and my run is 1. So instead of trying to, remember how maneuvering the mouse, your line starts going all crazy and it's hard to tell where you are? Use your rise using your arrow. How many do you need to rise? I need to rise 4. So I'm just going to hit my up arrow. Whoops. Oh, my up arrow doesn't work. Yours will work. And then run 1. So your right arrow. Maybe I need to. 1, 2, 3, 4. Now run 1. Right? So I did rise 4. That's fine, because you rose from 2. So you rose from 2 to 6. So how far did you rise? 4. And then you run 1. Now hit that and just hit enter. So count out your, I just realized that my up, down, left, right arrows on my laptop don't do what I want it to do, but yours on your keyboard do. and drop the, and hit enter. Once you've done your rise and your run, hit enter.
So on that problem, I would go up from 6.
Start your rise from your first point, from your Y-intercept point. So you rose 2. You only needed to rise 2. You needed to hit this 2 times. Rise 2, run 1. So you want to draw a line. Now, get off that. Now, rise 2, run 1. 1, 2, run 1. Hit enter. So that gets you off that mouse that goes crazy. Okay, now it is 10:48, so we are about past time. So we got a lot more to cover on Thursday. So if you aren't live on Thursday, make sure you tune. And we're going to be doing several more of these. I'm going to start with graphing using the slope and Y-intercept on Thursday.